Hello, welcome to the last pre-AMC 8 video for San Antonio Math Include as of now. I am Olivia, as always, and let's get started. So, I have no idea how to pronounce that name, is an avid reader. She bought a copy of the bestseller Math is Beautiful. On the first day, she read 1/5 of the pages plus 12 more. On the second day, she read 1/4 of the remaining pages plus 15 pages. And on the third day, she read 1/3 of the remaining pages plus 18 pages. She then realized that there were only 62 pages left to read, which she read the next day. How many pages are in this book? All right, let's take a look. So, on the last day, on the third day, she read 1/3 of the remaining pages plus 18. Right? Okay, so we're going to work backwards here. So after she read 1/3 of the remaining pages plus 18, she realized there were only 62 left to read, so 62. Before that, she read 18 pages. So there's 62 plus 18, that's 80 pages. And she had 80 pages left after reading 1/3 of the remaining pages. So 80, she read 1/3, and then she had 80 left. That was 2/3 of what was there before. Okay, so 80 represents the 2/3, we add another 1/3, right? So if 80 is the 2/3, how do we find 1/3? Well, find 1/3 by dividing it by 2, right? Because half of 2/3 is going to be 1/3, right? 2/3, you split it into 2, you get 1/3 and 1/3. So 40 plus 40 is going to make 80, and then 40 is the 1/3 that she already read, right? There's 3/3. She read 1/3, which was 40, and then had 80 left. So there was 120 pages before she read the 1/3 here. Okay, so we're up to here. Then before then, she read 15 pages. So add another 15, that's 135. Okay, and that was after she read 1/4 of the remaining pages. So in this case, the 135, that's 3/4 of what was left in the book up to that point. Okay, so the 135, that's 3/4, and we want 4/4, right? So to get to 4/4, we can find 1/4 and then multiply it by 4. Right? So what's 1/4 of 135? Well, we have 3 times 1/4, so we divide it by 3 to find 1/4, right? 3/4 is 3 times 1/4. So we do that division, 35 divided by 3, that's 45. Okay, so 45 is 1/4, multiply that by 4 to get 4/4, that's 180 pages. Okay, so that's where we're at here. Okay, at 180 pages, 12 more, right? Plus 12, that's at 192. Okay, and that is 4/5 of the pages. 192, that's 4/5. And now we want 5/5. Okay, so to get from 4/5 to 5/5, we'll divide it by 4 to get 1/5, and then multiply it by 5 to get 5/5. Right? So 192 divided by 4, that's 48. That's 1/5 is 48. So we'll multiply it by 5 to get 5/5, which is 240. There's 240 pages in the book. Answer choice C. Okay, the hundredths digit of a 3-digit number is 2 more than the units digit. The digits of the 3-digit number are reversed, and the result is subtracted from the original 3-digit number. What is the units digit of the result? Okay, so we've got a 3-digit number. The hundredths digit is 2 more than the units digit. So let's say the units digit is n for number. Then the hundredths digit is going to be 2 more, so n plus 2. Okay? The digits of the 3-digit number are reversed. So it's reversed, and now we've got n and n plus 2 here. And the result is subtracted from the original 3-digit number. What is the units digit of the result? So let's do some subtraction. So we're going to do n minus n plus 2. Okay? So we don't know what that middle digit is, we'll just call it x. So we'll do x minus 1. So now we have 1n. So that's like, if n is 7, we'd have 17, right? So we'll just write it as 10 plus n minus n plus 2, right? 10 plus n, we lose n plus 2. Okay? So n minus n, that's 0. Then we have 10 minus 2, that's 8. So our units digit is 8. And I'm just going to go over that again because I get that can be a little bit confusing. So remember, we have n plus 2, x for the middle digit, and then n. And we want to subtract from that n and n plus 2. So we can't do n minus n plus 2, right? Because n plus 2 is bigger than n, right? N plus 2 is bigger than n. So we have to borrow from the x, right? Borrowing. And that's going to add 10, right? When you borrow from the 10, you're going to add 10 to the ones place. So now suddenly we have n plus 10, right? Just like when I borrow doing 17 minus 8, I get rid of that, and now I have a 17 in the ones place. Or I could write that out as 7 plus 10. In that case, we'd have 7 plus 10 minus 8 and do it like that. Okay, so when I do n plus 10 minus n plus 2, n minus n is canceled out, right? N minus n is 0, and 10 minus 2 is 8. That's how we got the 8. All right, we got a semicircle, POQ and ROS pass through the center of the circle O. What is the ratio of the combined areas of the two semicircles to the area of the original circle? All right, let's find the area of the original circle. We see that it's centered in the center. Nice. And its radius goes outwards here to the point 1, 1. Right? So how do we find out the radius? We want to find this radius, and we know that Q is 1 unit over and 1 unit up. This is a distance of 1 and 1 from the origin. So how do we find what this radius is? Well, we can use Pythagorean theorem, right? 1 squared plus 1 squared equals our radius squared. So 2 equals our radius squared. Taking the square root of 2 equals our radius. So that's what this big radius is. Big radius is 2, or square root of 2. So the area of that large circle is radius squared. Square root of 2 times square root of 2 times pi, which equals 2 pi. Okay. What about the combined areas of the two semicircles? Well, we know that this semicircle, its radius is from here to here, right? That length. That's from a height of 1 to a height of 0. So this radius is just 1, right? So, and the same goes for the other semicircle. In fact, these semicircles could be part of the same circle, right? If you rotate it around, we've got this semicircle with radius 1. We could connect it to the other semicircle of radius 1 and just make a whole circle. So, the circle is radius 1. Its area is radius squared, 1 times pi. So its area is pi. Technically pi over 2 because it's a semicircle, but there are two semicircles, so we can combine them for an area of pi. Okay, we want the ratio of the combined areas of the semicircles, so that's pi, to the area of the circle O, which we found is 2 pi. So our ratio is pi over 2 pi. We can simplify, right? The pi's cancel, and we get 1 to 2. Answer choice B. Okay, what is the correct order of the three numbers 10 to the 8th, 5 to the 12th, and 2 to the 24th? Okay, let's start with 10. So 10 can be expressed as 2 to the 8th times 5 to the 8th. Okay, that seems really similar to, I noticed the 2, and that's really similar to 2 to the 24th. In fact, we can write 2 to the 24th as 2 to the 8th times 2 to the 16th. Okay, well, how does that compare to 2 to the 8th times 2 to the times 5 to the 8th? How can we compare 2 to the 16th and 5 to the 8th? Well, there's actually a way to do it. Let's think of 2 to the 16th as not 2 to the 16th, but instead of 2 squared to the 8th. So what I mean by that, we can think of it instead as 4 to the 8th power, right? 2 to the 16th is the same as 4 to the 8th. 2 to the 8th times 4 to the 8th compared to 2 to the 8th times 5 to the 8th. 2 to the 8th times 5 to the 8th is bigger, right? Because 5 is more than 4 in that case, and the 2 to the 8ths are both the same. So 10 to the 8th is more than 2 to the 24th. So we can cross out all of the ones where this isn't the case. That's D and E. Okay, what about 5 to the 12th? Well, 5 to the 12th actually has 5 to the 8th in it too, right? We can compare this to the 2 to the 8th times 5 to the 8th, right? Because 5 to the 12th is just 5 to the 8th times 5 to the 4th, right? And how does 2 to the 8th then compare to 5 to the 4th, right? Because we're comparing these two. 5 to the 8th cancel out, they're the same. How does 2 to the 8th compare to 5 to the 4th? Well, 2 to the 8th is actually 4 to the 4th. Okay. So now we're comparing 4 to the 4th and 5 to the 4th. 5 to the 4th is bigger, right? 5 to the 4th is more. So that means 5 to the 12th is also bigger than 10 to the 8th. So 5 to the 12th is the biggest. That gives us answer choice A, right? 5 to the 12th, then 10 to the 8th, then 2 to the 24th. Okay. Every day at school, Joe climbs a flight of stairs. Joe can take stairs 1, 2, or 3 at a time. So he could go 3, then 1, then 2, for example. How many ways can Joe climb the stairs? All right, let's look at our stairs. So the easiest way to do this is just to list out the steps, right? We've got step 1, 2, 3, 4, 5, 6. So how could Joe do this? Well, there's the fastest way, which is just to take steps 3 and 6. And then there's the longest way, which is to take every single step. And we can list out different iterations between them, right? Joe could instead do 1, 2, 3, 4, 6. Or 1, 2, 3, 5, 6. Or 1, 2, 4, 5, 6. 1, 3, 4, 5, 6. Or 2, 3, 4, 5, 6. So that's all 6 ways to skip a step. Or all 5 ways to skip a step, right? You can't skip the last step. Okay, so there's 1 way where you take all steps, 5 ways where you skip 1 step. What about the ways where you skip 2 in a row? Right? Joe could also go to 3, 4, 5, 6, or 1, 4, 5, 6, 1, 2, 5, 6, 1, 2, 3, 6. So that's 4 ways by skipping 2 steps in a row. Okay, what if you skip 2 steps not in a row? Okay, well then in that case you would go 1, 2, 4, 6, right? Skipping 3 and 5. 1, 3, 5, 6. 1, 3, 4, 6. 2, 3, 4, 6. 2, 3, 6. 2, 3, 5, 6. 2, 4, 5, 6. So that's another 4, 8, 9, 10 ways. Okay, what if you skip 3 stairs? So you could go 1, 3, no, you could go 2, 4, 6. It's another way. Or 2, 5, 6. It's another way. Or 3, 5, 6. Or 3, 4, 6. It's another 4 ways. Now we're at 24E. Okay, Margie bought 3 apples at a cost of 50 cents per apple. She paid with a $5 bill. How much change did Maggie receive? Okay, 3 apples at 50 cents per apple. So that's 50 cents per apple times 3. It's 150 cents. Or the same as $1.50. Right? She paid with a $5 bill. So we have $5 minus the $1.50 she spent. That equals $3.50. Answer choice E. Okay, we've got a garden 20 feet by 45 feet. Okay, we've got another one 25 by 40. Whose garden is larger? All right, well, let's compare. We've got 45 times 20. That's 900. And we've got 25 times 40. That is 1,000. So the 25 by 40 is larger. So that's McKenna's garden is larger. And that's by 100 square feet. Okay, extend the square pattern of 8 black and 17 white square tiles by attaching a border of black tiles around the square. What is the ratio of black tiles to white tiles in this extended pattern? Okay, the white tiles are going to stay the same, right? So right now we've got 17. Wait, do we have 17? We've got 17 white tiles. So that's what the outside is going to be. So white will be 17. How many black tiles do we have? What do we have when we extend it? So right now we have 8, but we're going to add, right? Add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So that's another 24. So we'll have 8 plus 24. That's 32. So we'll have 32 to 17. That's answer choice D. All right, a list of numbers of fish. Which statement about the mean, median, and mode of these numbers is true? All right, we want to find out which one, the sizes of each. So let's start with the mean. What's the mean? Actually, let's list them in order first. That'll make things a little less complicated. 0, 0, 1, 1, 2 2s, and 3 3s. Okay, our mean, we have to add them all up, divide by the total number. So 9, 10, 11, 12, 13, 14, 15 over 9, that's the mean. Okay, what about the median? The median is the number in the middle. That's this 2 right here. So 2 is the median. Then the mode is the number that appears the most. Our mode is 3. So our mode is the largest, right? We want the mode to be the biggest. It's going to eliminate some choices. Okay, and then what's bigger, the mean or the median? The median is 2, and the mean is less than 2, right? 15 over 9 is less than 2. So our median is bigger than our 9. Our median is bigger than our mean. So it goes mode, then median, then mean. Answer choice C. What time was it? 2011 minutes after the beginning of January 1st, 2011. Okay? So 2011 minutes, let's divide that into hours and minutes. So there's 60 minutes in an hour. So drawing this out, we get, 2011 divided by 60 times 3 is 18. So now I want 211 minutes. That's another 3. 18. That's 33 hours and 31 minutes. Okay? So 33 hours and 31 minutes after January 1st. It's going to be, well, there's 24 hours in a day, right? So it's going to be the next day because 33 hours is more than 24 hours. So we know it's going to be on January 2nd. So 33 hours minus the 24 because we already counted for it being the next day. That's 9 hours later. So it's 9 hours and 31 minutes after January 1st, after January 2nd starts. So that's January 2nd at 9:31 in the morning. Okay. In a town of 351 adults, every adult owns a car, a motorcycle, or both. 331 adults own cars and 45 own motorcycles. How many of the car owners do not own a motorcycle? So let's look at our Venn diagram. So in this, we've got car and motorcycle. So there's 331 adults who own cars. So that's the people who own the car, who own just a car, plus the people who own a car and a motorcycle, right? So that's the people in this space plus the people in this space account for the 331 adults who own a car, right? And now for the motorcycle, the 45 adults account for the people who own just a motorcycle. That's these people. Plus the people who own a car and a motorcycle. That's these people, because they also own a motorcycle. That equals 45. And we know that the people who own just a car, plus just a motorcycle, plus a car and a motorcycle, that's everybody, right? That's all 351 people. Because you either own just a car, just a motorcycle, or both. Okay. So how can we account for the number of people who do not own a motorcycle? That would be the just car people. Well, we know that the just motorcycle people and the car and the motorcycle people, so the people who don't own just a car, that's 45, right? Just motorcycle plus car and motorcycle, that's 45, according to this equation, right? So we can subtract that from our original equation to solve for the people who own just a car, right? Those are the people who don't own a motorcycle. So we get just motorcycle minus just motorcycle, that is crossed out. The car and the motorcycle minus car and a motorcycle, that gets crossed out. And now we want 351 minus 45. That equals 306 people. Answer choice D. All right. We've got 4 large congruent squares into combinations of congruent triangles or rectangles and is partially shaded. What percent of the total area is partially shaded? Okay, well in the first one we see that 1 out of the 4, so we got 1/4 of that, plus here we've got half of a quarter, right? It's divided into 4, and half of that is shaded, so half of a quarter, that's 1/8. Here we've got 1/4 plus another half of a quarter, right? Plus another eighth. So that equals 3/8. And in this one, it's another quarter. All right, we want percent of the total area. Well, we need to keep in mind that each of the squares represents a quarter of the area. So that quarter, this first quarter here, that's a quarter of a quarter, right? Because there's 4 squares, right? So 1 square is only a quarter of the entire stuff. So a quarter of a quarter, that's going to be 1/16. So this part here, the shaded in part, that's 1/16 of the entire 4 shapes. This eighth here, that's only a quarter. That's taking up 1/8 of a quarter of the thing. So we have to multiply that by 1/4 again. So that's 1/32 of the entire shapes. This part right here is 1/32. Here's another 1/4. So that's another 1/4 of 1/4. That's another 1/16. And lastly, this 3/8, that's 3/8 of 1/4 of the stuff, right? Not plus 1/14, I don't know what that was, times 1/4. So that's 3/32. So 1/16, we can turn that into 2/32. 2/32 plus 1/32 plus 2/32 plus 3/32. That is 8/32. Simplifying, they're both divisible by 8. That's 1/4. And we want 1/4 as a percentage. 1/4, that's 25 cents. That's 25%. Okay, bag A, you got 3 chips, 1, 3, and 5. Bag B has 3 chips, 2, 4, and 6. One chip is drawn from each bag. How many different values are possible for the sum of the two numbers? So we got 1, 3, and 5, 2, 4, and 6. All right, let's do some combinations. So we got 2 and 1, that would be 3. 2 and 3, that makes 5. 2 and 5, that makes 7. Okay. 1 and 4, that makes 5. 3 and 4, that makes 7. 4 and 5, that makes 9. Okay. 6 and 1 makes 7. 6 and 3 makes 9. 6 and 5 makes 11. So what have we double counted? Well, we've got a lot of 7s, but we've got 3s, 5, 7s, 9s, and an 11. So how many different possible values are there? I count 1, 2, 3, 4, 5 possible values. Answer choice B. Okay, Carmen takes a long bike ride on a hilly highway. The graph indicates the miles traveled during the time of her ride. What is Carmen's average speed for the entire ride in miles per hour? So here she travels 5 miles in 1 hour. So this stretch here, that's 5 miles per hour for 1 hour. Okay. Then she travels, well, here she goes from 5 to 10, from 5 to 15. So she goes another 10 miles in 1 hour. So in 1 hour, she went 10 miles per hour. So we got 10 miles per hour for 1 hour. Okay. Then we see she goes 5 miles in 2 hours, right? So that's 5 miles in 2 hours. Divide that by 2. That's 2.5 miles per hour for 2 hours. And then we see her go 5 miles per hour for 3 hours. And that's everything. So how many total miles did she go? Well, we can see here, Carmen made it 35 miles. And it took her 7 hours, right? 35 miles in 7 hours, that's 5 miles per hour. Answer choice E. Okay. You got taxi fare in Gotham City. Okay, so we paid $2.40 for the first half mile, so that's half a mile. And we've left a $2 tip. That's $4.40. How much money do we have left? We have $10 minus the $4.40. That's $5.60. All right. How many times could we pay the 20 cents needed for an additional 0.1 mile? Well, we'll divide our $5.60 by 0.2 cents, by 20 cents. We get that. We can bring our decimal place over. So now we have 2 divided by 56. That is 28. So there's 28 more times we could pay for another 0.1 mile. So 28 times 0.1 mile, we get another 2.8 miles out of it. So 2.8 plus 0.5, that's a total of 0.3 miles. Answer choice C. Okay, we've got the number of minutes studied by both Asha and Sasha in 1 week. On the average, how many more minutes per day did Sasha study than Asha? Okay, let's see how their difference was on Monday. So Asha is our black bar, Sasha is our gray bar. So on Monday, Asha studied for 60 minutes and Sasha studied another, we need 2 steps to get to 20, that's 10, right? Every bar measures 10. So we get 40, 50, 60, 70, 80, right? So Sasha studied 10 more minutes than Asha on Monday. So 10 more minutes. Okay. What about on Tuesday? On Tuesday, on Tuesday, Asha studied 90 minutes. That's 90 minutes. And Sasha studied 80 minutes. So on that day, she studied 10 less minutes than Asha, right? We got 10 more minutes on the first day, 10 less minutes. And when we have less minutes, we'll use a negative symbol. Okay, on Wednesday, Asha studied for 1 hour. For 100 minutes, 100 minutes. And Sasha studied for 120 minutes. So how much more did Sasha study? 120 minus 100. She studied for 20 more minutes. Okay, on Thursday, Asha studied for 80 minutes. Sasha studied for 110 minutes. Got 110 minus 80. That's another 30 minutes. And then lastly, on Friday, Asha studied for 70 minutes and Sasha studied for 50 minutes. So she studied 20 less minutes, right? So we want to make an average. So 10 plus negative 10 plus 20 more minutes plus 30 more minutes plus minus 20 more minutes, right? She studied 20 less minutes. Adding that up, 10 minus 10, 20 minus 20, we get 30 more minutes for 5 days. So she studied in total 30 minutes more over those 5 days. So we divide it by 5, we get 6 more minutes per day that Sasha studied than Asha. Okay, we've got Angie, Bridget, Carlos, and Diego seated at random around a square table, one person to a side. What's the probability that Angie and Carlos are seated opposite each other? Okay, so let's see Angie. Okay, let's say Angie sits right here. So we want the probability that Carlos is sitting there, right? Well, how many places can Carlos sit? Well, Carlos has 3 options, right? He can either sit here, here, or here. So Carlos has 3 choices, and only one of those 3 choices, right, this choice right here, will involve him sitting opposite Angie, right? So he's 1 out of 3 choices. There's a 1 in 3 chance that he's seated opposite her. It's answer choice B. Okay, we've got 2 congruent squares, ABCD and PQRS. They have side length 15. They overlap to form a 15 by 25 rectangle. Okay, AQRD as shown. Alright, this will be 15 by 25. What percent of the area of rectangle AQRD is shaded? Right, so our entire area of AQRD, that would be 15 times 25. Right? And we want to know what percent is shaded. So I'm just going to keep the 15 over 25. And let's figure out that shaded part. Well, if the 2 squares were put next to each other, right, they're 15 by 15 squares, what would the area of those 2 squares be? We'd have 15 here, 15 here, 15 here. That would be a 30 by 15 rectangle. Instead, it's moved over so that we've lost 5 units, right? It's scooted over 5 more, so we lose 5. Right? So this is scooted over 5. That means this square here is 5 by 15, right? 5 by 15. So the total shaded in area is 5 times 15, and we want to know what that is as a percent. So 5 times 15 over 15 times 25. Well, we can simplify it. We can cancel out our 15s. We got 5 over 25. That's the same as 1 over 5. So 1 over 5, how do we write that as a percent? 1 over 5. We want something over 100. So how do we get from 5 to 100? We multiply by 20. How do we get from 1 to what we want? We'll also multiply by 20, right? Whatever you do to the bottom, you do to the top. We get 20%. Answer choice C. Okay. 270 students at Colfax Middle School, where the ratio of boys to girls is 5 to 4. There's 180 students at Winthrop, where the ratio of boys to girls is 4 to 5. The 2 schools hold a dance, and all students from both schools attend. What fraction of the students at the dance are girls? Okay, well, we have 270 students from one school and 180 from the other, so there's a total of 450 students, right? And we know that the girls at Colfax are 5 to 4, right? So 5, that's the boys, plus 4, it's the girls, that equals 270. Boys plus girls is 270. So how do we figure out how many are girls? Well, if 5 to 4 is the ratio, that means the total is 9. 5 boys and 4 girls is going to make 9 overall. So 270 divided by 9, that's 30. And we want 4, right? Because our ratio is 4 for the girls. So we do 30 times 4, that's 120 girls at Colfax. And the rest are boys. What about at Winthrop? We know the ratio of boys to girls is 4 to 5. So that means the total again is 9, right? Our ratio of girls to total would be 5 to 9 in that case. So 180 divided by 9, we have 20. So 20 represents 1 in this case. And we want 5, right? If 20 is 1, we want 5. We'll multiply 20 times 5. That's 100 girls at Winthrop. So what fraction of the students at the dance are girls? Well, there's 120 plus 100. That's 220 girls out of 450 total. What does that simplify to? 22 over 45. Answer choice C. Okay, how many digits are in the product of 4 to the 5th times 5 to the 10th? Well, let's say you have a number 8, right? And you multiply it by 10. That adds a 0, right? Every time you multiply something by 10, you add another digit, right? It just puts a 0 at the end. So why am I telling you this? Well, it's because 10, that's 2 times 5. And here, we've got some things that maybe don't look like 2's yet, but they could be 2's, and some 5's. So let's work with that. Well, 4 is just 2 squared, right? 4 is 2 squared. So instead of writing 4 to the 5th, we can write 2 squared to the 5th power. Simplifying that equals 2 to the 10th, right? 2 times 5 would make it 10. So basically, it's asking us how many digits are in the product of 2 to the 10th times 5 to the 10th. And better yet, it's asking us how many digits are in the product 10 to the 10th. Right? We're multiplying them together. For every 2, there's a 5. So, in 10 to the 1st, we've got 1 0. That's 2 digits. 10 squared, that's 100. That's 3 digits. 10 cubed, that's 1,000. There's 4 digits. So it's going to be 1 more than our exponent, which is 10. We're going to have 11 digits in 4 to the 5th times 5 to the 10th. Answer choice D.